Long before modern air conditioning, ancient civilizations devised ingenious ways to stay cool. In Egypt, people hung wet reeds in windows. As breezes passed through, the water evaporated and cooled the air. Similarly, the Romans circulated aqueduct water through their walls to reduce indoor heat, a primitive form of climate control. In ancient China, wealthy families used handheld fans and large rotary fans powered by servants. The Chinese also harvested ice from mountain lakes in winter to preserve it in underground ice houses for summer use. These early cooling methods were labor-intensive, but showed a deep understanding of thermodynamics. The Islamic and Persian worlds introduced architectural innovations like wind catchers and qanats. Wind catchers funneled cooler air into homes, while qanats, a system of underground water channels, helped lower temperatures naturally. These systems inspired later designs in hot climates, such as those in southern Spain and North Africa. In 1758, Benjamin Franklin and chemist John Hadley conducted experiments in which they used alcohol and ether to accelerate evaporation. They demonstrated that the process could cool an object below the freezing point of water. Though not practical at the time, this work laid a theoretical foundation for future innovations. The first real attempt at mechanical cooling came in the 1830s from American physician Dr. John Gorrie. He believed that cooling the air could prevent the spread of diseases like malaria and yellow fever. Gorrie built a machine that compressed air to produce ice, which he used to cool hospital rooms. Despite his visionary work, Gorrie struggled to find financial backing. His ice-making machine was patented in 1851, but its commercial prospects were limited. Gorrie died in relative obscurity, never seeing his dream of widespread cooling realized. By the late 19th century, the need for temperature control was rising in industrial settings. Printing plants, textile mills, and food manufacturers all required humidity regulation to maintain quality and efficiency. These needs set the stage for the invention of modern air conditioning. In 1902, Willis Carrier, a 25-year-old engineer, created the first modern air conditioning system. He was hired to solve a humidity problem at the Sackett-Wilhelms Printing Company in Brooklyn, where moist air was causing ink to misalign on paper. Carrier's system worked by drawing air through coils cooled by water. As the air passed through, its moisture condensed and was removed, effectively reducing both humidity and temperature. This dual-function innovation revolutionized industrial air control. In 1915, Carrier joined with other engineers to form the Carrier Engineering Corporation. The company focused on bringing air conditioning to commercial and public spaces, including factories, hospitals, and office buildings. Their success transformed the perception of cooling from luxury to necessity. Air conditioning entered the public eye in the 1920s, particularly in movie theaters. The Rivoli Theatre in New York City was among the first to feature air conditioning, turning summer moviegoing into a popular escape from the heat. Cool indoor air became a strong marketing tool. Residential use followed, but slowly. In the 1930s, companies like General Electric and Frigidaire introduced window air conditioning units. These early models were expensive and bulky, limiting their accessibility to only the wealthy elite. After World War II, a booming economy and mass production made air conditioning more affordable. Suburban homes were built with central air in mind, and manufacturers developed smaller, more efficient units. By the 1950s and 60s, air conditioning became a common household feature in the United States. The availability of air conditioning reshaped architecture. Previously, buildings relied on features like high ceilings, verandas, and cross-ventilation to stay cool. With mechanical cooling, architects could design sealed, glass-covered skyscrapers and low-ventilation homes. As economies in Asia, Latin America, and the Middle East developed, air conditioning spread globally. In hot, humid climates, it improved quality of life, worker productivity, and public health. It also made new urban development possible in previously inhospitable regions. However, environmental concerns emerged by the 1970s. The refrigerants used in most air conditioners, chlorofluorocarbons, CFCs, were found to deplete the ozone layer. This led to the 1987 Montreal Protocol, an international treaty that phased out harmful substances. In response, manufacturers developed more eco-friendly refrigerants and energy-efficient systems. Innovations like inverter compressors, programmable thermostats, and better insulation helped reduce the environmental impact of cooling systems. Despite improvements, air conditioning contributes significantly to global energy consumption and greenhouse gas emissions. The irony is stark. The more the planet warms, the more we rely on cooling, which in turn accelerates warming. Finding sustainable solutions is a pressing challenge. Modern air conditioning is increasingly integrated with smart technologies. Systems now feature Wi-Fi connectivity, AI-driven optimization, and real-time energy tracking. These advancements help users manage comfort while reducing energy costs. The story of air conditioning reflects humanity's pursuit of comfort and health through technology. As we face rising global temperatures, the focus shifts to making cooling more sustainable, accessible, and environmentally responsible for future generations. Thanks for watching!